Hi, and welcome to the homework 5 solution video. So our first problem is so define a sequence recursively by f of 0 equals 0 and f of 1 is equal to 1 and f of n is the remainder of the previous two terms divided by 3 for all n greater than or equal to 2. So the sequence starts like this. So we have to find the sum of 8 consecutive terms. So firstly, we can write out the first few terms: 0, 1, 1, 2, 0, 2, 2, 1, 0, 1, 1. We don't actually didn't have to go that far because we have two sequences, appearances of 0, 1. So that means this sequence is just going to repeat 0, 1, 1, 2, 0, 2, 2, 1. So its period is 1, 2, 3, 4, 5, 6, 7, 8. Now we're adding 8 consecutive terms, so this is actually just the sum of the first 8 terms. So 1 plus 1 plus 2 plus 2 plus 2 plus 1 is equal to 9. Okay, problem 2. Positive integers a, b, and c are randomly and independently selected with replacement from this set. What is the probability that ABC plus AB plus A is divisible by 3? There's an extra E here for some reason. So firstly, we'll factor this as A times BC plus B plus 1. So A is divisible by 3, or BC plus B plus 1 is divisible by 3. So firstly, the probability of it being divisible by 3, well, 2010 is a multiple of 3, so it's just 1/3. And then the probability of this number being divisible by 3. Okay, so firstly, we actually have to multiply by 2/3 because we'll only get to this case if A is not divisible by 3. So this case we will only get to if A isn't divisible by 3, which has a 2/3 probability, and then the probability of this being divisible by 3. So let's consider the possible remainders of B. So B can be 1 mod 3, 2 mod 3, or 0 mod 3. So we're going to find what values of C can make this divisible by 3 in each of these cases. So if B equal is 1 mod 3, then C is 1 mod 3. You can check that this makes this divisible by 3. If B is 2 mod 3, then C is 0 mod 3. Again, you can check that. And if B is 0 mod 3, then it's actually impossible for this to be divisible by 3. So like there are 9 choices for combinations of B's value mod 3 and C's value mod 3 because they both have 3 and 3 times 3 is 9. And out of those 9 combinations, 2 of them work, 1, 1, and 2, 0. So the probability of this one is 2/9. So 2/3 of 2/9 is 4/27. So now we just have to add these. You get 13/27. Okay, problem C. 3. A palindrome is a number that has the same value when read from left to right. There was a previous problem about palindromes in a different homework, I think. For example, this number is a palindrome. Let this be the least three-digit integer, which is not a palindrome, but is the sum of three distinct two-digit palindromes. So what is the sum of the digits of this number? So basically, we're looking for the smallest non-palindrome DEF that can be written like this. So notice that all of these three numbers are multiples of 11, so their sum is also a multiple of 11. So let's just look at the first few multiples of 11. The first three-digit multiple of 11 is 110, which just so happens not to be a palindrome. So if we can write this as such a sum, then n is 110, so our answer will be 2. We can indeed write it like that. 11 plus 33 plus 66 is equal to 110. So 1 plus 1 plus 0 equals 2. Okay, so our fourth problem asks us to find a unit digit of some expression where k is this thing. Okay, so we can find the unit digit of these two parts individually. So for the first part, we need the unit digit of k. So let's find the unit digit of k. The units digit of 2008 to the 2 is just the unit digit of 8 to the 2, which is 4. For the unit digit of 2 to the 2008, we know 2's period is 4, and the remainder of 2008 divided by 4 is just 0. So our 2 to the 4 ends with a 6. So the other units digit is a 6. So the units digit is going to be 0 to the power of 2 is going to be 0, 10. So that's the units digit of the first one. Now let's find the units digit of 2 to the k. So again, we know 2's order is 4. So we need to find the remainder of this number divisible by when divided by 4. It's pretty easy to see that both of these parts are themselves divisible by 4. So k is also divisible by 4. So 2 to the any multiple of 4, we already know will end with a 6. So the answer is 6. A whole number larger than 2 leaves a remainder of 2 when divided by each of 3, 4, 5, and 6. The smallest such number lies in which of these ranges? Okay, so suppose this number is n. So if it leaves a remainder of 2 when divided by these, and minus 2 is divisible by 3, 4, 5, and 6. So n minus 2 is going to be the LCM of, that's not a C, LCM of 3, 4, 5, 6, which is equal to 60. So n is going to be equal to 62, which is from 60 to 79. And problem 6. How many whole numbers between 99 and 999 contain exactly 1 0? So notice that these are just the three-digit numbers A, B, C. So the first digit can't be a 0, so it's either of the form A0C or AC0, AB0. So the case A0C, A can be any number from 1 to 9, and C can be any number from 1 to 9. C can't be 0 because exactly 1, 0. So this has 9 times 9 equals 81. Um, in this case, both A and B can be any number from 1 to 9. Pretty similar to the first one. 9 times 9 equals 81. So 81 plus 81 is equal to 162. Okay, thanks.